Impacts and Collisions 2012, question 5b. A smooth sphere P collides with an identical smooth sphere Q, which is at rest. The velocity of P before impact makes an angle alpha with a line of centers. At impact, and alpha is between 0 and 90, so this is my alpha in here and in here. The velocity of P is deflected through an angle theta, which is here, by the collision, and the coefficient of restitution is 1/3. Show tan theta is equal to 2 tan alpha over 1 plus 3 tan squared alpha. Okay, if we look at P, we'll call the speed u here because we have no, it's not telling us what the speed is. So u cos alpha times I, the initial velocities, plus u sine alpha times j. Q is at rest. To get, we know from previous questions doing these, the tan of this angle, the tan of theta plus alpha, is going to be my j velocity after impact over my I velocity after. There's no change in j. I is the only thing that changes. So no change in j. So we need this I after, which is going to be our V1. So if we apply the principle of conservation of momentum to this question, we're going to get mu1 plus mu2 is equal to mv1 plus mv2. Now they're identical spheres, so we can say they're both m. So mu cos alpha plus m times 0, q is at rest, is equal to mv1 plus mv2. Divide by m, and we're going to get u cos alpha is equal to v1 plus v2. We have the coefficient of restitution now for my Newton's experimental law. So Newton's experimental law, v1 minus v2. You can write it with the u1 minus u2 underneath, or you can write it up here. So v1 minus v2 is equal to minus 1/3 times u cos alpha minus 0. So we're going to get 3v1 minus 3v2 is equal to minus u cos alpha. So we want v1 in this question. If we multiply this one by 3 and bring it down, we're going to get 3u cos alpha is equal to 3v1 plus 3v2. So that's going to give me 6v1 is equal to 2u cos alpha. So v1 is equal to, it's going to be 2 over 6, or u cos alpha over 3, or 2 over 6 if you want to write it that way. So applying this to my tan theta plus alpha, now there is a trigonometric identity here, the tan of a plus b, which is what we need. You can see from what they're looking for in the question, we're going to need a trig identity here. We're going to end up with sine over cos, which will turn it into tan for the tan of theta plus alpha. So tan a plus b is equal to tan a, and we'll call our a plus b alpha plus theta. So we're looking at tan a plus tan b, which is alpha plus theta in our case, over 1 minus tan a tan b, which is tan alpha tan theta. So we also know that the tan of alpha plus theta is equal to, as we said, the j velocity over the I velocity. The j velocity, you can see, was u sine alpha over here on the left. So we have u sine alpha, and v1, which we've just gotten, is this guy here, u cos alpha over 3, which is equal to 3u sine alpha over u cos alpha. I can divide by u and turn my sine over cos into tan. So this is equal to 3 tan alpha, which is also equal to this guy here. So just by cross multiplying, allowing these to be equal to each other, we should get to our answer. So tan alpha plus tan theta over 1 minus tan alpha tan theta is equal to 3 tan alpha. So cross multiply by 3 tan alpha, we're going to get 3 tan alpha minus 3 tan squared alpha, tan alpha by tan theta, equals tan alpha plus tan theta, rub that out, tan alpha plus tan theta. So just check, we're looking for this in terms of tan theta, so we want tan theta on its own, don't we? So tan theta on its own. So let's get tan theta on its own by bringing this one to the left. 3 tan alpha minus tan alpha is going to give me 2 tan alpha, equals, bring this one over to the right, 3 tan squared alpha tan theta plus tan theta. So now I can factorize tan theta out of these two to get it on its own. Tan theta by 3 tan squared alpha plus 1 is equal to 2 tan alpha. So dividing by 3 tan squared alpha plus 1, we're going to get 2 tan alpha divided by 3 tan squared alpha plus 1 is equal to tan theta. Is this what they were looking for? 2 tan alpha over 3 tan squared alpha plus 1. 2 tan alpha over 1 plus 3 tan squared alpha, which is what we have.